Distinguished colleagues, we are to start our session, but right now we have a problem with connection with one of the members of the board, therefore I announce the first technical break. The first technical break is over. And we start the panel session. Once again, good afternoon, distinguished colleagues and guests. It's the 12th of March, 2021. And it's 14:08. And we're beginning the panel session for the defense of the thesis by Ilya Busko. The thesis is submitted for the academic degree of the candidate of technical sciences. The specialization is 051301, system analysis, management and information processing, technical sciences. The topic of the thesis is identification of C-wave parameters in onboard intelligence system. Our dissertation board was appointed by the decree of the academic secretary of St. Petersburg State University as of December the 1st, 2020. Number 11144/1. And Yevgeny Veremey was appointed the chairperson of the board. However, unfortunately, he passed away. Therefore, I announce the minute of silence. Thank you. Under the order issued by St. Petersburg State University as of March 25, 2021, number 1589/1, I, Alexander Bogdanov, Doctor of Sciences in Physics and Mathematics, Professor of the Department of Space Technologies and Applied Astrodynamics of St. Petersburg State University, was appointed the chair of this dissertation board. Let me introduce the members of the board. Alexander Vadyacha, Doctor of Technical Sciences, Professor of the St. Petersburg Electrotechnical University, LETI. Then Mikhail Gnatich, Doctor of Sciences in Physics and Mathematics, Professor of the Faculty of Science of Pavel and Joseph Shafarik University in Košice, Slovakia. And Kirill Rozdestensky, Doctor of Technical Sciences, Professor of St. Petersburg Marine Technical University, is working remotely today. Honorary Scientist of Russia. Do you hear us and see us? Yes, I do. And we also have our candidate for the degree, Ilya Busko. As well as the academic advisor, Professor Alexander Degtyaryov, Doctor of Technical Sciences and Professor of the Department of Computer Modeling and Microprocessing Systems. And I would like to inform you that the panel session of the dissertation board is being recorded and broadcast on the St. Petersburg State University website, and it is also interpreted into English. Currently, we have an email address posted on the page with live broadcast of the board session, and all the listeners can submit their questions to Mr. Busko online. The questions regarding the thesis or scientific discussion, these questions will be forwarded to me by our technical service, and I will read them out during the discussion. Questions must be related to the presentation and the content of the thesis. And don't forget to give your name and position if you submit a question. Questions that have nothing to do with the scientific discussion or dissertation will not be voiced. Under the order on the procedure of granting academic degrees at St. Petersburg State University, approved by local normative acts, the session of the dissertation board is valid, providing 2/3 of the appointed board members are present. The total number is not to be fewer than 4 people. Our dissertation board consists of 5 people, 4 are here today, including 1 member of the board, working remotely. We have a multimedia connection with all the members of the board as well as with our candidate for the degree, therefore we have a quorum. And our session should not last more than 2 hours, And the agenda is as follows. First comes the chairman's presentation about the documents submitted by the candidate for the degree and their conformity with the requirements. Then chairman's replies to questions, if any. 5 minutes for that. Next comes candidate's presentation, providing an overview and findings of the research. 15 minutes for that. Then questions to the candidate regarding the presentation, no more than 2 minutes per question. Then candidate's replies to the questions, 10 minutes for all. Then reports on the thesis. The board members will be taking the floor in turns to provide their reviews and questions. Then the chairman's report on the thesis, 10 minutes for that. Then the candidate's comments about the report on the thesis and replies to the questions. Then open discussion. Anyone present at the defense may state their position or ask questions on the thesis. Ten minutes per speaker. And kindly fill in the registration form and introduce yourself before I give you the floor. Then the chairman will ask the questions submitted during the broadcast via our website. Then candidates' replies to the questions. Presentation of the candidate's thesis supervisor. Then 5-minute discussion before the open balloting on conferring or non-conferring the academic degree. The discussion of the results is not broadcast. 5 minutes for that. Then open balloting, vote counting and recording the results in the protocol. Then making a decision on whether to confer the academic degree or not. And finally, the candidate's closing speech. 10 minutes for that. Distinguished colleagues, any questions or objections? None. Okay. Let us proceed. Before we do that, I kindly ask you to switch off the sound on your mobile phones. Thank you. So, let me start. The chairman's presentation. The thesis by Ilya Busko for the academic degree of the candidate of technical sciences, specialization 0513-01, system analysis management and information processing, technical sciences, is titled Identification of C-wave parameters in onboard intelligence system. The thesis was approved for the defense by the order of the Academic Secretary of St. Petersburg State University, Alexander Knyadov, issued December 2nd, 2020, number 10931/1. Ilya Busko has prepared his study at St. Petersburg State University, and Professor Alexander Dekhtyaryov, Doctor of Technical Sciences, Computer Modeling and Microprocessing Systems Department of St. Petersburg State University, is the academic supervisor. 8 published works describe the research findings. They include 2 papers published in peer-reviewed journals recommended by the Ministry of Education and Science, and 1 paper in publications indexed in Web of Science and Scopus. The candidate has submitted the full set of documents to the Academic Secretary. The above-mentioned documents comply with Item 12 of Section 3 of the Order on the Procedure of Granting Academic Degrees at St. Petersburg State University, and as far as I am informed, all the documents comply with the requirements and are kept in the certification file. The Curator of the Defense, member of the Department of Dissertation Board Support, has all the copies. And before I give the floor to our candidate for the degree, I would like to ask the members of the board if there are any general questions to the candidate for the degree, and is there a need to consider the full list of documents submitted? No need for that. Okay. No questions, therefore I would like to give the floor to Mr. Busko. Ilya, please, you have the floor. 15 minutes. Dear distinguished chairman, distinguished members of the board, ladies and gentlemen, my name is Ilya Busko, and the topic of my research is the identification of sea wave parameters in onboard intelligence system. Providing safety of navigation is one of the relevant topics. One of the most important issues is to define the weather conditions in which the vessel is being operated, and also to define the progress of development, and we should also understand how it will influence the vessel. Throughout history, people were working on the topic, and it is not resolved up until today. The main difficulty is in the boundless character of the ocean, and also in the fact that the existing current systems are very costly and hard to install, and the approaches are not quite developed, and there is a need to take into account the peculiarities of the vessel at the current point of navigation. The safety of vessel operation can be improved if we improve the weather forecast in advance, and all the approaches are divided into two: instrumental and meteorological ones. The information that is provided by a meteorological approach is of a generalized character, and it does not take into account the specificity of a separate vessel and the area of navigation. And as for instrumental approach, we have the ship measurement, wave measurement system, and also water space radio location systems. They have certain drawbacks. For example, they are not measuring with 100% accuracy, and they are also costly. And for the first time, the dynamic oscillation approach was tested in the 80s. And also it was defined in 1990 by Professor Nechayev. And as for the advantages, here we have permanent measurements. And at the same time, the measurement is done in that very point of the world ocean where the vessel currently is. Then we take into account the peculiarities of the vessel, and it's also quite accessible and cheap. As for the drawbacks, here we have inaccurate information on the vessel as a buoy, and the problems connected with reverse problems. As I've already mentioned, the identification problem for external impact is a reverse problem, and a reverse problem is an incorrect problem, in order to resolve which we should have additional information and use additional limitations. And in order to improve the accuracy of the resolution, we should have a lot of additional information, and the resolution of this problem is possible if we use a linear equation and use Werner-Hintgen theorem. If the interaction of the sea and the vessel has a non-linear character, we offer to linearize it. Then also we have a noise component and insignificant and unknown parameters of the model, and we have certain limitations on that as well. And when this approach was developed, we saw a lot of works that were based on it, but the weather forecast goal was still unresolved. The goal of the work is to analyze different parameters of wave formation, and this additional information is the climate spectrum, because it fully reflects the ensemble of wave weathers characteristic for this very region. And in order to resolve the problem, we should have met the following goals. First of all, we should have analyzed the identification on the information that we have in the climate spectrum, and we should compare it with additional information that other researchers use. Then we should have analyzed the noise and the parameters of the model. Then also we should have taken into account several degrees of freedom, and we should have established the distributed information processing system. The analysis of foreign sources has shown that in order to improve the accuracy of calculations, they use a lot of additional information and additional limitations, and they organize preliminary calculations. For example, in some works, they try to calculate the transfer function in advance, and in some others they define spectral density and are looking for integral indications. But they don't fully use the knowledge of the physics of the studied object. And I offered to use the full knowledge of physics of the marine wave, and as this information I offered to use the climate spectrum. The climate spectrum is a set of wave weathers characteristic for this region and season that has characteristic wave formation conditions, and it contains not just typical wave weathers, but also it defines the most probable scenarios of development and rotation of storms. Thus, in tables 1 and 2, we can see examples of climatic spectra for a specific region. As climate spectrum has approximations of all wave weathers, they are the ones that are used in the interaction model. And this novelty changes the problem setting. Restore the form and define which approximation describes wave formation at this point of time. And this brings us the new identification algorithm. And this one is different from the existing ones. And you can see it in articles 3 to 5. We know the spectra of all the possible wave weathers, and we use them in the formulas connected with a Werner-Hintschen theorem. And we check the calculations and check the results according to the spectrum. And as for foreign scientists, they describe an algorithm of the best calculations or integral indications, or peak of maximum energy from the measured values. Thus, the first provision taken for the defense is the new algorithm of identification based on this climatic spectrum. Then we carried out an analysis of noise and parameters impact on restoration of the model. First of all, we use a particular case and then a general case. And on images 3 and 4, you can see examples of the influence of a damping coefficient and self-frequency of oscillation of the vessel. And on image 5, we can see the influence of noise on the overall system. The transfer to the general case was in the analysis of the location of self-frequency of the vessel and the frequency of the peaks. And on images 6 and 7, you can see the examples of the influence of damping coefficient and the square of self-oscillation. And to the left you see the graphs in which self-oscillation is close to peak, and in the right that they are quite remotely located. And this analysis gave us the following result. We concluded that noise and parameters of the model do not shift the energy peak. However, in some high values of noise and location of self-frequency, the restoration can be impossible. And due to the difference of rolling and pitching oscillation, we carried out the analysis of this simultaneous these simultaneous factors, and we found out that using two oscillations for restoration at the same time, we can restore several plots of our spectral density, and this may be enough in order to define which approximation of the climate spectrum describes the wave formation at this period of time. And this analysis gave us the second provision on simultaneous simultaneous calculation of different types of oscillations. And in order to process information, we should analyze sub-problems. The first sub-problem is the reading of is taking the readings of the sensors and initial processing of this information, and also its storage. This work should be carried out separately and in parallel. The reasons here are that the information on acceleration is helps to define the linearization of the process, and it is the basis of Wiener-Kenshin theorem. And Professor Nechayev, by the way, demonstrated it, and I use his approach. If the modules of averaged amplitudes of acceleration are located at different areas, this process is linear. And also there's a need to correct the navigation conditions, and it requires less intervals to calculate acceleration. And a quasi-stationary interval, it takes 20 minutes here, but the size of the sliding window can be 3 minutes, 5 minutes, and so on, and it can change. So we should have an opportunity to use this information from the sensors and for other applications. And the storage is performed. The storage of this information is performed, and this information is sent to other blocks and to other applications. And the calculations are carried out real time, and at the same time we should have an opportunity to use some competing algorithms for calculation, both spectra and some preliminary calculations. And also we should have a user's interface that should provide the necessary information and the opportunity to manage the system. We should have a failure-resistant system. If some part of the system fails, the work of the system is not violated. And this analysis gave us the third provision of the algorithms of distributed data processing. And it can be implemented in the following way. One node is working with readings and processing of initial data and storage. Second node is working with the storage and the distribution across the hubs. And the third one is dealing with calculations and gets the data from the storage, carries out calculations, and sends them back to the storage, and uses interface certainly. That reflects all the information and allows to manage the system. And if one of the nodes fails, we should have an opportunity to reconfigure the system so that one of the working nodes would perform these functions. And we developed a new algorithm of identification, and we demonstrated that we can improve the identification mechanism, taking into account several axes of freedom at the same time, and we offer this system of distributed information processing. As for the scientific novelty, we have the application of new additional information like climate spectrum in the algorithm of identification of wave formation parameter. And on this slide, you see the works published on the topic. Thank you so much. Thank you. We can start the discussion, and I would like to ask if any members of the board have questions on the report. Could you please tell me what response time do you need? Half a second, and second question. Do you have a ready-made system in the market that you can buy? No, with such algorithms we don't have such equipment. Kirill, any questions? The following one. What data can support this interesting algorithm? Well, unfortunately, I don't have good metadata. Therefore, in practice, this algorithm was not checked. This will be the next step in the development of this approach. And what are the prospects of the processing of this climate spectra for major navigation areas? Because you need to correlate it with time. Well, Well, what is this time prospect? When can you get this data to calculate everything for these 5 most popular routes? For the most busy pathways. Well, to that end, you should organize in-situ testing, and right now we don't see this such questions. Okay, I would like to ask the following question. On at different conferences, I heard that there are places in the world ocean, Naples Bay, a place near Rotterdam, and near Yuzhno-Sakhalinsk, where wave formation parameters change if we consider the 1.5 kilometer distance. Is this approach relevant when you see such a change of parameters? In this case, these parameters won't be used for these regions. Therefore, we need to introduce additional calculations here for such areas. Okay. And now we shift to the speeches of the board members, and you have an opportunity to answer each question. Each board member, or you can answer all the questions at once. I'll answer the questions after the review. Okay, first of all, I would like to give the floor to Mikhail Ignatich. Thank you so much. Well, I won't read out my review because anyone can read it on the website. I'll just give certain important points. The thesis of Ilya Busko is dedicated to the development of identification methods for parameters of wave formation based on information processing on the character of the vessel. I would like to emphasize the relevance of this topic, and it is relevant because we have a lot of marine navigation routes considering the current economic ties. And now a few interesting points on the topic dealing with technology itself. So it's hard to imagine a clear solution if you don't linearize the system of wave formation in sea. And you see this approximation ways to linearized systems. And what's of particular importance is that the author offers to use the concept of the climate spectrum or wave climate, and the author mentioned that in his report, and I believe that this approach is a novel one. And then we have questions. There are 5 of them. I believe you'll read them out. Well, I don't have them with me. Okay, then I'll do that. I can read them out. So, here they are. The identification procedure is developed for linear or quasi-linear process of interaction. It would be interesting to get certain assessments for strong non-linear processes. That's the first question. The second question, in all calculations, there is independence of the studied values from spatial coordinates, as far as I understood. And can we use this approach in order to take into account such dependency and give approximate estimations of the marine area in which you can use this local forecast? Third question. In the work you mentioned 3 axes of freedom, but during the calculation you used just 2 of them, the rolling and the pitching oscillation. And can you also assess other types of oscillation? In fourth question, in the basic equations that you gave, the external influence on the vessel is taken into account as additive noise. And this influence of the environment could be used as multiplicative noise. I believe you know what it is. When, for example, this function is multiplied by a variable, which is the basic one in the equation, or by any other function from it. And could you please assess the relevance of this approach. Maybe the results will be changed, and maybe these calculation schemes can be applied for such a case. And the last question, not rather a question, but rather a comment. There's a range of misprints that really damages the impression. For example, such word as parameters, and you don't give all the values in the linear equation 2.3. And also, it would be wonderful to have better images, and you don't sign the axis in your images as well. But still, that does not compromise the overall value of the thesis, and the results are quite relevant. Therefore, I believe that the thesis by Ilya Busko, titled Identification of C-wave Parameters in Onboard Intelligence Systems, meets the requirements of the orders of September 1st, 2016 on the procedure of granting academic degrees at St. Petersburg State University, and Mr. Busko deserves the academic degree of the candidate of technical sciences in Specialization 051301 System Analysis, Management and Information Processing, Technical Sciences, and Article 11 of the above-mentioned order is not violated. That's it. Thank you very much. Thank you so much. Please, the answer. Thank you so much for the questions. The first question dealing with linear interaction and non-linear interaction. Non-linear interaction may be the development, a step for development in the future, and linear and quasi-linear was chosen for two reasons. First of all, in this case, we can use Vladimirovich theorem, and navigation conditions could be corrected in order to get a quasi-linear response. A second question. As for the navigation areas and forecasts, the size of the navigation area depends on climate spectrum, and this is the size that we, this is the area that we provide our forecast for, and also it depends on the type of the reservoir. Is it open, like ocean, open sea, or inland sea, where the forecast can be given for 10 or 20 kilometers if we talk about inland water sources. And as for the size of the region, I don't influence them. I just use the works on climate spectra that oceanologists prepare. And as for the use of rolling and pitching oscillations and other types of oscillation, the first two oscillations were chosen because they are different from each other. And due to that, for example, we can resolve the problem of finding the personal frequency of the vessel along with the frequency of the peak. If they are close, the patching oscillation will be a bit different, and this will allow us to restore a plot of the spectrum. And the vertical oscillation was not considered because it is registered. It's quite hard to register it technically. And as for other types of oscillation, longitudinal or cross-sectional, and also griping, they don't have a restoration moment. And a rolling and pitching oscillation, they are not interdependent, so you don't need to take into account this rather specific peculiarity. The fourth question on the additiveness and multiplication of the noise. In this work, I didn't have this goal to consider types of noise. And therefore, the most general case was used when we added additive noise, when I just added this component. And multiplicative noise, maybe we should take it into account in case of turbulence. And when I considered the solutions, I did not see such cases. Okay, I got it. But technically, you can take that into account. Yes, we can. And as for the last a remark. Well, I believe you just should agree with that. I beg pardon for that. Yes, certainly, that's it. Certainly, I agree, and I beg your pardon for that. Okay, so Alexander. I would like to start with the relevance. Who needs it and why? When we are talking about the safety of navigation, that's a permanent topic and it's clear that it's relevant. The second point of relevance, why didn't we do that before? Because we didn't have this computational capacity to perform such calculations, and right now we have contemporary approaches to this construction. That's Internet of Things, and we have marginal calculations there, and they have very good servers like Raspberry where you can do that. Therefore, we can't do that right now. We can perform such calculations. Therefore, that's quite a timely work when we have this technical opportunity to do that. And as for the work itself, the work is given for the first specialization, and that's a classical work, I would say. I haven't seen such works for a very long time because you have this management element. Why do we need this work? In order to manage the vessel. So basically, it's one of the services that can be implemented, and if it won't be implemented, then the case will be just worse. And that's a very good help. And then this work can also be used in different fields. And now a question on the initial data and the fact that they were not collected. Well, they're going to do that. You can do it differently. It's clear what to do with them, but maybe there was no demand for that previously. And overall, the work creates a very good impression. I'm not an expert in navigation, you see, but I understand differential equations and the implementation that this can be done. And indeed, I understand that you can do it real time. So that's an important point. And the author, I believe the author understands the topic quite well. It's clear what should be added up to the equation, and we know that it will work. Therefore, I believe that the work is performed at a very good level with a good understanding of the context. Because why do we need that? Why are we doing that? This work? What do I think is a user? That's the collection of some context information about what's happening around, and you can take a decision based on that. So that's an element of a larger system. Overall, the work is very good. I liked it a lot, and I give you 2 comments. First one. As that's a system analysis specialization, the first question, who is the main stakeholder? Who is the main stakeholder, and what are the interests of the stakeholders? And the second question, it's unclear what do you mean by this word combination, intelligence system? That's classics, you know. That's a classical question. But these drawbacks do not compromise the value of this work, both practical and theoretical one. The work resolves a very relevant problem. It has practical importance, and the thesis by Ilya Busko meets the basic requirements of the order on the procedure of granting academic degrees at St. Petersburg State University. And the candidate for the degree, Mr. Busko, deserves the academic degree of the candidate of technical sciences and specialization, system analysis, management and information processing, technical sciences. And Article 11 of the above-mentioned order is not violated. Thank you. Thank you very much. The answers. Thank you very much for the questions. Should I repeat? No, I remember them. The first question on the stakeholder. who may need that, and what's the use of this situation currently. As the global ocean is not well studied, especially if we consider the climate spectrum, we have such studies for some small areas, for example, the Black Sea. So this work may be important for those companies that are performing shipments in very closed areas. This will help to organize the work. For example, we get a general forecast from meteorologists that in 10 hours we're going to have a storm. And we can use this algorithm to specify the forecast for a specific vessel. And we will be able to define whether we will be able to make the transfer before the storm becomes dangerous for us or not. Or maybe we can perform part of transfer or part of work. As for the second question on the intellectual system, well, here I see the system that's working with creative problems developed for a specific subject. Intelligent systems have 3 blocks: database of knowledge, solver, and intellectual interface. The formalization of the climatic spectra themselves, and also the processing of data and processing of calculations as retrospective information of the past. So these all are suitable as a database. And take into account the fact that this algorithm can be applied in the calculations of spectral density, and we can also add up noise component or something else. We are doing it based on the conditions in which we have this vessel, based on the conditions in which we find ourselves, considering oscillation. So that's a kind of solver that shows us the logic of choice of some or other algorithms for this particular time. And the third point, user's interface. User should first of all see the information and have this ability to reconfigure the system. Here we can also say that users, as experienced sailors, can give their assessment to the result of the work of this application. So this can take into account some additional information, and this can be an attempt to use our algorithm as well. Okay, thank you very much. Kirill, please. Dear colleagues, I'll start with formal conclusion first of all. This work, identification of sea-wave parameters in onboard intelligence systems, meets the requirements of the orders of September the 1st, 2016, on the procedure of granting academic degrees at St. Petersburg State University, and Ilya Busko deserves the academic degree of the candidate of technical sciences in specialization, system analysis, management, and information processing technical sciences. And Article 11 of the above-mentioned order is not violated. So that's where I want to start. And I believe that's quite a huge topic, and we know it quite well at our university, because we've used the works of Professor Nechayev a lot. And you know, he was quite a visionary at his period of time, because now we have a lot of opportunities that he previously mentioned. This boundless ocean, lots of navigation areas and lots of navigation pathways, changing weather, and therefore we have certain spectral localizations, and we also see this very interesting definition of climate spectrum that can systematize all the procedures of defining of such spectra for the most complicated navigation seas. And his works were continued by his students, for example, Professor Degtyaryov, whose thesis was dedicated to the modeling of wave formation. And here it turns out that you need to take into account both wave formation, and you should model oscillation using quite rational equation system. And also, it is important to consider this opportunity of identification using two main types of oscillation: the rolling one and the pitching one. It's very interesting indeed, and it seemed to me that it works quite well when these types of oscillations are not interdependent. This approach gives us an opportunity to, get brand new opportunities. And it's of particular importance that we would see the shift of these critical frequencies. And to this end, they are quite, for these types of oscillation, they really shifted. And by the way, this was well shown in the today's report. And this brings us closer to an opportunity to work in real time, to take into account the current progress in the development of neuron systems. And today we also consider the development of autonomous navigation, and also certainly it would be wonderful to reduce the time of passage and save fuel. I won't mention the content of the thesis and the structure of it. It was already mentioned in my review. But I would like to say a few words about the comments and questions. There's no exact explanation of the emergence of oscillations in the restoration of the spectrum. Maybe it is connected with the unstable decision of the reverse problem of the restoration of the spectrum. And now I read this question once again and believe that there is this explanation in the work. Then it would be wonderful to give the climate spectrum for a specific navigation area, and all for specific vessel and for specific type of oscillation at a chosen interval of time. That's rather, such a question on in-situ tests, and I believe that's just a wish for your future work. As for the systems, I've already mentioned, it's important that you use two-dimensional freedom here. It's not quite clear how they will influence each other, but this choice of rolling and pitching oscillation, that's a good choice anyway. And once again, I'd like to mention that I like the work a lot, and I believe that, sure enough, it should be continued, and maybe the author will continue his academic career. Certainly this work is quite in demand among navigation experts and military sailors in the Navy, and also in automated vessel operation systems. So once again, I'd like to mention that I have a very positive impression on the work, and thank you very much for the chance to read it. Kirill, do I get it right that you raised questions in your review, and the candidate for the degree answered these questions in his report? Yes, because his report helped me to understand the real situation, so we can ignore these questions. Okay. Well, I find myself in quite a beneficial position, you know. Everything was already mentioned, but I would like to add just one point. This work was already introduced into practice in Marintech. That's one of our St. Petersburg leaders in information technologies for navigation, for shipbuilding. And that's a very important component of this work. Therefore, I'll just shift to the most important part. And indeed, I have certain comments, but basically part of them is to show that I've really read this work. I won't read them out, but I'll just read out one comment. It can be discussed, I believe. I had such an impression that you've developed a certain toolkit, and this toolkit is a contribution for users that can use this toolkit and apply it in practice for certain goals. But I didn't have an impression that this toolkit gives us answers to the questions in the first chapter. Well, that's not a conclusion, I believe. Did you fully answer the questions in the first chapter or not? That's the question that I wanted to ask. Thank you very much for the question. Well, this work was mostly an analytical one, and in order to answer questions correctly about the efficiency of the restoration of oscillation using this approach, you should apply in situ testing. And if you take, for example, information for a specific area that already has climate spectrum and organize a lot of tests and check everything about the restoration of the algorithm, we can thus develop some approximate assessments for the region. Okay. Therefore, I can easily state that my comments do not compromise the overall high value of this work because it provides answers to relevant practical problems. And the thesis by Ilya Busko meets the requirements of the order as of September the 1st, 2016 on the procedure of granting academic degrees at St. Petersburg State University. And Mr. Busko deserves the academic degree of the candidate of technical sciences and specialization, system analysis management and information processing, technical sciences, and Article 11 of the above-mentioned order is not violated. And in order to proceed, I want to ask the members of the board if they are satisfied with the discussion. Did they get all the answers? Yes, okay. And now I have the following question. Did we get external reviews? None, okay. Did we get any questions then? No. Okay, then we're drawing a line here. If there are no questions right now, we believe that there are no questions at all. I would like to ask if anyone not the member of the board wants to speak out. No one. Okay. Okay, then I believe we can proceed. And I would like to give the floor to the academic supervisor. Please, Alexander Borisovich, tell us about the candidate for the degree. Mostly about the candidate for the degree and less about his work. Dear Chairman, dear members of the board, I'll try to be short. You see, Ilya has been working on the topic for a very long period of time, and certainly I believe he could define his thesis much earlier, but there were certain interruptions. He was the first PhD student here at St. Petersburg State University when I joined the university 10 years ago. he graduated from our faculty, applied mathematics, then joined our PhD course, and he chose this topic. He was interested in it, but due to the fact that his education was mostly a mathematical one, it took a lot of time to understand this navigation, thermodynamics, oscillation, oceanology, and other things. But his preparation, his academic training allowed him to have this very systemic approach, and finally he sorted everything out. After he graduated from his postgraduate studies, he went to work, and this work was, finishing at the point when he was already working on a different topic in a different field. So he was earning money, earning his living in IT sector. Therefore, this is not a very quickly written thesis, but still this work was going on, and I'm quite satisfied with the fact that he finally defended it, and I believe it gave us very interesting results. I'm really satisfied with the fact that Ilya worked with me, and also he did not abolish it after he graduated, and for 5 years or even more he was continuing his studies. Therefore it was interesting to him, therefore he needed that. Therefore I believe that he is an established scientist, because if a person is working with in science when he already works in IT in a separate field, in industrial programming and so on, it means that the person really deserves this academic degree. That's it. Thank you very much. Thank you. Our program is coming to an end, and I would like to ask anyone present, or maybe members of the board, if there are any questions that we did not mention. None. Okay. Does anyone want to say something? Something else? No. No, no. Okay, now it's 15:05 and we stop our discussions here. We have no external questions or reviews, and we can shift to the discussion. I would like to ask the members of the board if there is a need to turn off the broadcasting and discuss the results between ourselves, to discuss the questions that will not be given for the open discussion. No need for that. Okay, we're not going to interrupt the broadcasting. So, we are to discuss the results then. Therefore, I raise a question on the award of the academic degree of the candidate of technical sciences and specialization 051301 to Ilya Busko. And I would like to remind you that the decision of the recitation board on conferring the academic degree is positive, provided more than 50% of the board members, but not fewer than 3 people, voted in favor, in conformity with section 23 of the order. Therefore, I kindly ask you to give your opinions. First of all, Mikhail Ignatich, what's your opinion? I vote for the award of the academic degree. Okay, thank you. Then, Alexander Vadyacha, please. I vote for the award of the academic degree as well. Okay, thank you. Please, Mr. Rozdesensky. I also vote for the award of the academic degree. Okay, thank you. And I, Chairman of the Board, Alexander Bogdanov, also vote for the award of the academic degree. Therefore, distinguished guests and colleagues, I would like to announce that out of the 4 members of the board who participated in the vote, 4 voted for the award of the academic degree, no one voted against it, and no one abstained from the vote. So the decision on the award of the academic degree of the candidate of technical sciences to Ilya Busko is made. So, distinguished colleagues, due to the fact that our session is held remotely, I would like to ask the members of the board or the candidate for the degree if there are any questions on the procedure of the session. No comments? None? No? It turned off itself, the microphone. Okay, now the finalizing remarks of our candidate for the degree. I would like to thank my thesis supervisor, Alexander Dikteryov, for all these years of interesting work and the fact that we got a positive result, and the topic is really interesting for us. And I come from Belarus. We don't have seas near our borders, so for us this topic is of particular interest. Okay, thank you very much. Therefore, I close our session, and I would like to thank everyone, and I kindly ask to turn off the broadcasting.